Our solar system. Take a look. The striking infrared images were taken this summer by the James Webb Space Telescope.
Imagine pointing humanity's most powerful space telescope at the edge of our solar system, only to witness a planetary catastrophe unfolding in real time. The James Webb Space Telescope, with its razor-sharp infrared eyes, had been quietly scanning the outer planets when it stumbled upon something no one expected. Neptune, icy, distant, and shrouded in mystery, flashed an unmistakable signal in Webb's data. A signal that could only mean one thing: something massive had just slammed into the ice giant. In an instant, astronomers were stunned. The thermal patterns, the shock waves, the strange fingerprints in Neptune's atmosphere all pointed to a cosmic collision so violent that it shook a world nearly 4 times the size of Earth. For centuries, Neptune was just a mathematical prediction, a ghost in the machine of celestial mechanics, inferred from the wobble in Uranus's orbit. Before we dive deeper into this incredible event, make sure to smash that like button and subscribe for more updates from the frontiers of space. Even after we found it, it remained a faint, fuzzy dot in our best telescopes, guarding its secrets behind a veil of distance. Neptune has always been an enigma. Almost 3 billion miles from the Sun, it receives just a whisper of sunlight. The Voyager 2 flyby in 1989 was humanity's only close encounter, revealing roaring supersonic winds, raging storms, and that deep sapphire blue color from methane gas. We knew it was big, blue, windy. Its winds are the fastest in the solar system, whipping methane clouds at supersonic speeds. Since then, scientists have relied on Earth-based observatories and, most recently, Webb's powerful vision. But never, not once, had we witnessed a direct impact on Neptune, until now. Because the solar system isn't a set of isolated spheres, it's a dynamic, interconnected family, and Neptune is one of its oldest members. Webb's instruments captured a sudden eruption of heat blasting upward through Neptune's atmosphere, alongside chemical fingerprints that betrayed an intruder, foreign material injected into the planet's skies. The elements that make up this giant were forged in the same swirling nebula of gas and dust that also gave birth to Earth. This wasn't a pebble, it wasn't even a small asteroid. The impactor had to be tens or hundreds of kilometers wide, likely a rogue comet or icy object dislodged from the Kuiper Belt. Enter the hero of our story, the James Webb Space Telescope, or JWST. This isn't just another telescope, it's a marvel of human ingenuity. When it plunged into Neptune's thick atmosphere of hydrogen, helium, and methane, it didn't create a crater like on Earth. Instead, it triggered supersonic shock waves, dissolved and scattered its exotic ices, carbon compounds, ammonia, carbon dioxide, into Neptune's swirling hydrogen seas. The energy released? Equivalent to millions of nuclear bombs detonating at once. Its primary mirror, a stunning honeycomb of gold-plated beryllium segments, over 6 times larger in area than its famous predecessor, Hubble. Neptune is already the most chaotic planet in the solar system, with winds topping 1,500 miles per hour. But Webb's follow-up observations revealed something stranger: unusual bright spots and twisting cloud bands, patterns unlike anything recorded before. These disturbances may be the atmospheric scars of the collision, fleeting echoes of the violence that just unfolded. Webb sees the universe in a different kind of light. Infrared is the light of heat. Infrared is the light of hidden things. Even more fascinating, Webb detected chemical fingerprints unlike Neptune's native makeup. These signatures act as a cosmic autopsy, telling scientists exactly what the object was made of. If it was a Kuiper Belt wanderer, its chemistry could be a time capsule from the birth of the solar system. For planets like Neptune, infrared lets us peer beneath the top layers of the atmosphere. Temperatures, pressures, chemical compositions. For decades, Neptune seemed like a tranquil giant, drifting silently at the edge of the sun's light. But this event proves otherwise. The outer solar system is still dangerous, still alive, and still capable of violent surprises. It's like having a planetary CAT scan machine. Webb reveals structure and dynamics that were invisible, turning a static blue marble into a living, breathing world. Collisions aren't just ancient relics of planetary formation, they are an ongoing reality. On Earth, they've wiped out dinosaurs and shaped the course of evolution. On gas and ice giants, they may be fueling storms, redistributing chemistry, and even altering global circulation. Webb's capture of this impact is more than a planetary drama. It's a window into how worlds evolve across the galaxy. Because if it happens here on Neptune, it almost certainly happens on distant exoplanets orbiting alien suns. That Webb happened to be watching Neptune at precisely the right moment, underscores its role as far more than just a deep space galaxy hunter. Suspended beyond Earth's atmosphere, it is free from the distortions that limit ground-based observatories, giving it the power to catch fleeting events with breathtaking clarity. In this case, Webb did not just peer into the ancient past, it became a sentinel, catching a planetary collision in real time. On what would have been an otherwise routine day of observation in late 2024, the James Webb Space Telescope was pointed toward Neptune, gathering data for a long-term study of its atmospheric dynamics. This discovery reminds us that Webb is not only a tool for exploring galaxies billions of light-years away, but also a vigilant observer of our own solar system. And it raises profound questions about Neptune itself, long regarded as a kind of gravitational gatekeeper at the edge of the Sun's domain. Neptune's orbit lies just inside the Kuiper Belt, a vast cemetery of icy bodies left over from the birth of the planets. For billions of years, Neptune's gravity has acted like a cosmic sculptor, trapping some of these bodies in orbital resonances while flinging others into interstellar darkness. It is entirely possible that the very collision Webb witnessed was the end result of this gravitational influence, an object nudged inward by Neptune itself, only to meet its doom against the very planet that set it on that path. In the stream of data flowing back to Earth, something extraordinary appeared. In this sense, the impact is a reminder that the solar system is not a static arrangement, but an ongoing dance of gravitational cause and effect. Planets and small bodies shape one another in subtle tugs, and sometimes in catastrophic encounters. For astronomers who study exoplanets, Neptune's drama carries a wider significance. Many worlds discovered around distant stars are gas and ice giants like Neptune orbiting far from their suns. The processes shaping them, impacts, atmospheric disturbances, chemical injections, are likely mirrored in those alien systems. By observing this collision here at home, scientists gain a rare opportunity to decode similar signals from exoplanets across the galaxy. Every spectral fingerprint Webb gathered from Neptune becomes a key for unlocking the hidden stories of worlds light-years away. A brilliant momentary flash of thermal energy in Neptune's northern hemisphere. It was a burst of heat so intense and so sudden that it stood out against the cold backdrop of the planet's upper atmosphere like a cosmic firework. But the implications reach even closer to home. This event is also a vivid lesson in planetary defense. Earth, to some extent, is shielded by the giant planets. Jupiter, Saturn, Uranus, and Neptune act as cosmic guardians, sweeping up or deflecting debris that might otherwise threaten our fragile world. Watching Neptune absorb the energy of such a massive impact is both a warning and a reassurance. The solar system is dangerous, but its giants sacrifice themselves to protect the inner planets. Yet Neptune's collision is not simply a story of violence. It has also revealed chemical mysteries. Some of Webb's data did not match any known compounds, hinting that exotic reactions may have occurred as the intruder's material fused with Neptune's atmosphere. Molecules rarely seen elsewhere in the solar system may now linger in Neptune's skies, waiting for astrochemists to unravel their secrets. The scientific team, staring at their monitors in disbelief, quickly ruled out instrumental glitches. The data was clean. What they were seeing was real. Even the heat signature surprised scientists. Instead of fading quickly, the thermal glow persisted, suggesting the impact's energy plunged deeper into Neptune's enigmatic interior. Beneath its stormy clouds, pressures grow so immense that water transforms into supersonic ice, a bizarre state of matter found nowhere on Earth. The collision may have disturbed these hidden layers, offering clues to questions that have haunted planetary science for decades. What truly lies beneath the atmospheres of ice giants? And the ripple effects extend beyond Neptune itself. Its faint rings, fragile and shifting, may have been fed new dust by the debris. Its moons, including the captured Kuiper Belt giant Triton, may have felt subtle changes in their orbits, shifts too small to detect today but significant over centuries. The event connects to Neptune's deeper story, a world constantly reshaped by outsiders, whether captured moons or wandering comets. They had witnessed, for the first time in human history, a large-scale impact event on one of the outer gas giants in real time. Seen in this light, the collision Webb recorded is not an isolated accident, but part of the ongoing choreography that has sculpted our solar system since its birth. Collisions built planets, reshaped their atmospheres, and sometimes destroyed entire worlds. They are destructive and creative at once, tearing down old structures while planting the seeds for new ones. The evidence pointed towards something much denser. The leading theory, a rogue Kuiper Belt object, a leftover building block of the solar system. This single moment on Neptune becomes a cosmic mirror, reflecting the forces that shaped Earth itself and that continue to shape worlds across the universe. For every collision we witness, thousands more occur unseen in the dark. Yet Webb has given us the rare gift of catching one in the act, transforming Neptune from a distant blue dot into a living stage for cosmic drama. Likely between 50 and 100 kilometers across, a mountain of rock and ice hurtling through space at tens of thousands of kilometers per hour. In fire and ice, the story of the solar system is still being written. Neptune's collision is both a revelation and an invitation, an urgent reminder that the cosmos is alive with motion, and even the most remote planets are still shaping, still changing, still telling their stories. As it plunged into Neptune's thick atmosphere, friction heated it to an incandescent glow, turning it into a massive fireball. Deep within Neptune, matter behaves in ways almost unimaginable. Water crushed into supersonic ice, flowing like a liquid yet ordered like a crystal. Exotic ices that under immense pressure conduct electricity. Layers that churn and twist, giving rise to the planet's strangely tilted magnetic field. A collision of the magnitude Webb recorded may have plunged into these mysterious depths, disturbing convection currents or stirring chemical layers in ways we can only begin to guess. No solid crater like on Earth or the Moon. Instead, an airburst, exploding deep within the clouds. The explosion vaporized the object instantly, sending a colossal shockwave that dredged up deep material. We cannot see these regions directly, but their disturbances may reveal themselves indirectly, through changes in Neptune's magnetic field, shifts in its auroras, or subtle variations in its thermal glow. Even before the impact, Neptune was already a puzzle, radiating more heat than it receives from the sun, as though hidden furnaces burn within. By jarring this delicate system, the impact may have created a natural laboratory in planetary physics, a chance to watch how heat, chemistry, and magnetism evolve in real time. The raw energy injected into Neptune's atmosphere began to churn and evolve, seeding the formation of a brand new, gigantic storm system. The glowing scar left by the explosion became the heart of a swirling vortex. The implications reach far beyond Neptune. Thousands of exoplanets have been discovered, many of them gas and ice giants eerily similar in size and mass. But what shapes their appearances, their atmospheres, their storms? One of the greatest challenges in exoplanet science is accounting for rare but transformative events like collisions. A distant hot Neptune might show strange chemistry or heat signatures that are really scars of an ancient impact. Without a reference from our own solar system, such anomalies would remain mysteries. Now, with Webb's observation, astronomers can begin building a library of impact fingerprints, chemical enrichments, odd heat patterns, shifting clouds, that may unlock the secrets of alien worlds. Webb's spectrographs detected signatures of molecules that are not supposed to exist in Neptune's upper atmosphere. We saw evidence of complex hydrocarbons, and most surprisingly, a significant abundance of water vapor. Speculation extends further still. Neptune shares its frontier with a vast population of icy wanderers in the Kuiper Belt. If one object was nudged inward to strike, might others eventually follow? Over cosmic time, could Neptune endure multiple collisions, each one subtly reshaping its atmosphere, its heat balance, even its fierce supersonic winds? Each strike would be imperceptible on human timescales but decisive over billions of years, slowly rewriting the planet's evolution. It confirmed long-held theories about Neptune's deep interior composition and provided the first direct observational evidence. And yet, beyond the science, there is philosophy. Collisions remind us of the universe's indifference. Worlds may drift in serenity for eons only to be violently transformed in an instant. For humanity, watching from Earth, such spectacles are humbling. They remind us that the same forces that once bombarded our planet still shape the solar system. Ceaseless, impartial, creative, and destructive all at once. This single event has forced us to fundamentally reevaluate our model of the modern solar system. The solar system is still a shooting gallery. For Neptune, the story is far from over. As it recovers, scientists will watch for storms that may arise from injected heat, cloud systems altered by foreign chemistry, or auroras intensified by a disturbed magnetic field. Even the faint rings may brighten with fresh dust, while distant moons could feel slight shifts in their orbits. Every ripple becomes data, a grand experiment orchestrated by nature, impossible to replicate in any lab. If an object 100 kilometers across can hit Neptune, It means bodies of that size are on unstable orbits. This makes tracking near-Earth objects (NEOs) all the more critical. The event also rekindles a call for exploration. Voyager 2 gave us our only close look at Neptune more than 3 decades ago. Since then, it has been left to telescopes and patience. If Webb can reveal so much from a million miles away at L2, what revelations might a dedicated orbiter uncover, watching from up close as the aftershocks unfold? The scars on Neptune serve as a powerful cosmic lesson in impermanence and change. We look at the planets as timeless and eternal fixtures of the night sky, but this is an illusion born of our short lifespans. There are lessons here for planetary defense as well. Though Neptune bore the blow, the event is a reminder of the violence that still lurks in the solar system. Earth is shielded in part by its giant neighbors, who sweep up or deflect many potential threats. Neptune's collision is both a sacrifice and a safeguard, providing crucial data about how bodies are drawn inward and how often they might cross Earth's path. The impact on Neptune is a dramatic demonstration of how creation and destruction are two sides of the same coin, and woven through it all is culture. For millennia, humanity has woven myths around the heavens, gods, omens, and cosmic portents. Neptune himself, god of the sea, now struck by a wandering body, feels like myth reborn in scientific truth. Webb has shown us that while the tridents of gods no longer cross the sky, the cosmos still stages spectacles of power and awe. This event highlights the value of persistent long-term observation. We found this because we were looking. As data pours in, Neptune's collision becomes more than a planetary drama. It becomes part of a larger narrative about the nature of change itself. It echoes the ancient impacts that tilted Uranus, birthed Earth's moon, and perhaps seeded our world with the chemistry of life. It offers a living link between past and present, between our solar system and countless others. You might ask, why should I care about a storm on a planet 4 billion kilometers away? It doesn't affect my daily life. But it does something else. It feeds the soul. Collisions build, collisions destroy, collisions transform. In Neptune's skies we saw all three at once, and Webb has ensured that this time, humanity was there to witness it. Stories like this have the power to inspire the next generation. A child today who reads about this cosmic collision might be the scientist who in 30 years designs the mission that finally sends a probe deep into Neptune's atmosphere. The impact on Neptune does more than scar a distant world. It gives us a calibration point for the cosmos. Its aftermath can refine climate models not just for Neptune but for exoplanets, where similar disturbances might arise from collisions or even violent stellar flares. The James Webb Space Telescope is an international collaboration, a project that brought together thousands of minds from different countries and cultures, all working toward a common goal. This connection is profound. Many exoplanets have shown puzzling chemical signatures, heavy metals, strange molecular ratios, or unexpected enrichments that don't fit with steady-state atmospheres. One hypothesis is that these are not permanent features at all, but momentary scars, evidence of recent impacts or in falling debris that briefly pollute an atmosphere. With Neptune's collision, we now have a nearby test case. By comparing Webb's data from Neptune with the spectra of distant exoplanets, astronomers can distinguish stable planetary chemistry from violent, short-lived anomalies. Without such calibration, a world might appear rich in methane or carbon dioxide, not because of long-term climate, but because it was struck only recently. The universe has a wonderful habit of being more magnificent and more surprising than we imagine. Every time we build a new instrument and point it at the sky, we find things we never expected, but the implications reach deeper. Neptune harbors one of the strangest magnetic fields in the solar system, tilted, offset, restless. A collision energetic enough to stir its atmosphere may also have disturbed this magnetic system, altering currents and triggering new auroral storms. Such phenomena could temporarily light Neptune's poles with intensified displays of charged particles. Observing these shifts provides rare insight into how magnetospheres react to sudden jolts, knowledge that echoes back to Earth, where our own magnetic shield defends against solar storms. Understanding these dynamics sharpens our ability to predict and mitigate the hazards of space weather across the galaxy. As long as we keep listening to that voice, as long as we continue to explore, we will continue to make discoveries that enrich our lives, expand our minds, and redefine our place in the universe. And then there is Neptune's role as the outer solar system's great architect. For centuries it has acted as a cosmic shepherd, guiding, capturing, and scattering trans-Neptunian objects across eccentric orbits. The very fact that a collision was detected shows this architecture is not static. Neptune is still shaping the frontier, still pulling bodies inward, still pruning and sculpting the Kuiper belt across billions of miles. Each impact becomes a note in a larger symphony of gravitational evolution, reminding us that the solar system remains a work in progress. So, the next time you look up at the night sky, remember Neptune. Remember the flash, the storm, the incredible story it told us. In the end, Neptune's collision is not an isolated event. It is a window into planetary physics, into the life cycles of atmospheres, into the resilience of magnetic fields, and into the slow, grinding architecture of the solar system itself. It ties the fate of a single ice giant to the mysteries of distant exoplanets, and even to the shield that protects our own world. Remember that we are living in an age of unprecedented discovery. Let that fill you with a sense of wonder, let it inspire you, and keep looking up. The show is just getting started. So, we must ask, was this just a natural accident, a cosmic inevitability, or something far more mysterious? Share your thoughts below, and if you found this journey into Neptune's secrets fascinating, give this video a like and subscribe for more explorations of the universe's hidden dramas. Until next time, thank you for watching.